to irrigate that, what happens is that almost half of your crop dies. So in organic food, if you have 1 acre, you only get 50% yield. So that's why if you buy organic tomatoes, it's going to cost you at least double the price of a normal tomato, because the production yield is very low. Now, so we established organic food is better because it's not treated with chemicals, the yield is low. Wouldn't it be absolutely fantastic if we can actually have food that is not exposed to chemicals and at the same time have high production? That would be wonderful, because then I get very healthy food and I'm not facing all the problems of organic or pesticides. That's exactly what nanotechnology is doing at the moment. Basically, the idea that you see here, on the left you see these balls. These are shells that are about 50 to 60 nanometer big. And these shells, they are normal organic material shells. We use them in soap. Some of these materials are practically what you have in soap. They're built into a shell, engineered, and the shell contains inside of it, as you see on the schematics here on the right, whatever chemicals you have. The shells are engineered in a way that they will only open up under certain conditions. The shells are 100% water soluble. What you see on the left is a number of these shells on a concrete surface going through temperature cycles from minus 50 degrees up to almost 200 degrees, about 3,000 of these cycles. So you have the concrete, the shell, and they keep changing the temperature from minus 50 to 200, 3,000 times. And as you can see, for 10 weeks, the shells did not open. If you put pressure on them, they will not open. The only thing that will make them open is the trigger you engineered into it. And in this case, the trigger is the change in pH. All of us, our stomach is acidic. Most of the crops, most of the pests actually are alkaline in their stomach. So it is engineered that when you reach a certain alkaline level, the shell opens. This will only happen when the pest eats the shell. If I eat the shell, it's not going to open and release the chemicals in my stomach. When it is dispersed over the crop, it's not going to open. It's just there. You can wash it out with water, it will get out. But it's only opening when the pest eats it. Basically, this is targeted delivery of your pesticide. So, me as a human, the soil, the plant are not exposed to the chemicals. It is only the pest is exposed to the chemicals. So, it's an old idea, but we now can do it with nanotechnology, and this is actually has been done for cotton, rice, peanuts, soya beans, and it is working very well. Following the idea of drug delivery for fertilizers, basically what you see here is engineering the fertilizer to only, this is here herbicides, الحشيش. المزارع عندنا في مصر في كل حته في الدنيا بتعاني من مشكله اسمها الحشيش. الحشيش بيطلع ويخش جوه الزرع، يعمل مع الزرع. And it really takes a lot of the food, the water from the crop itself. So we have to get rid of, أنا بتكلم عن الحشيش اللي هو النجيلة. So the idea is they want to get rid of it. And basically the problem is you can either have a huge area, you go pick it up by hand, and that's very difficult. Or you can use chemicals, but the chemicals can also kill your normal plant. So what can we do? We engineer it. This is not bioengineering, this is not genetic engineering. This is just simply chemical engineering. You know how the receptors in the plant look like, in the grass, in the wheat that you want to get rid of. And you engineer your fertilizers that they will only tag the wheat. And that's basically what is going on. So you can kill the wheat very effectively. The second thing, in agriculture, these are very simple. These are to some crops that are treated with, again, nanomaterials to help them withstand high temperature, low water. And as you can see, well, the image is not that great, I'm sorry about that. This is on the left, this is rice. On the left, this is normal rice. On the right, this is rice treated with nanomaterials. And you can get 35% increase in your yield using this technology. For wheat, this is to withstand very cold temperature. You got 97% survive the winter if you treat them, versus 17% if you don't. So this has a huge implication, this technology, for countries like us, developing countries. I'm not going to go into this one. I'm going to change now. So we've discussed water. First thing I read was used through a little bit of a history of nanotechnology. We talked about what is the STMs, an economy microscope, that allows us to see the molecules on the surface. This has a lot of applications for surface treatment. I've seen you the atomic force microscopy, where we look at the image where we see the topography versus the friction on the surface, and this has a lot of applications in metal alloys. Then we moved into applications in water, and the message there was, if we have the technology, we can build these water filters at a very cheap rate compared to what we can acquire them if we buy them from outside. And it's all very simple technology, it's not that difficult. The third thing I've seen you is in agriculture, and how we can use nanotechnology without genetically engineering the plant or the crop, or genetically engineering the soil, into how to achieve a better yield, a much more healthier crop price. Now what I'm going to move into is insulation. Now this is more for the architects and the construction engineers. Now, when you run your air conditioning back at home, when it is really very warm outside, your air conditioner has to run for a longer time because it's trying to keep the temperature inside the house cooler. The problem is the walls are sending heat from outside. Now in Europe and in the States, when they build the house, they actually put insulating material between the walls. In Egypt we cannot do that anymore because actually our buildings are built. So the only way to put insulating material is to demolish all the house and put insulating material in. That, of course, is absolutely ridiculous. This is uneconomical. But at the same time, the number of air conditioning units we have at our home are increasing, which means energy consumption is increasing. So we're paying a lot more for electricity. Electricity prices are going higher and higher. It has environmental implications. So we need a solution. One of the easiest ways to solve this problem is provided by nanotechnology. Basically, if you remember the second movie I showed you, 6 millimeters, 900 degrees color. The same technology can actually be used in paint. To just paint. So when I'm painting this wall or this wall, I'm actually providing heat insulation. This is information coming from a house that was completely treated with nano paint and nano insulating material. And what you can see in red and yellow and blue, this is the normal energy consumption from April until October of the house. And you can see that in August, September, you're consuming about 4,000 kilowatts of energy to cool down the house. Now, in 2008, the house was completely treated with nanomaterial, which is the green side, and this is just paint. When you paint your room, you can use this material and paint the room. You can see you almost achieved 50% reduction in your electricity consumption. 50%. Now, this is technology that is very interesting, but unfortunately in Egypt we cannot apply it in houses because the price of electricity for domestic use is subsidized and we cannot compete with that. But for industrial application, it makes a lot of sense. Because industrial applications nowadays are paying full price for electricity. Now what you see here, this is a boiler, and boilers can be in food processing industry, can be in textiles, can be in leather production, but handmade basically. Any industry that has boilers. One of the things you need to do in a boiler is you keep continuously giving it energy to keep the water boiling. But there's a lot of heat coming out from the walls of the boiler, and this heat is a lost energy that keeps coming out. If you can shut down this lost energy, you actually